Assalamualaikum and hi. My name is AMIRUL HAKIMI bin Abu Bakar and my metric number is B0519101007. The objective of this project is to analyze and improving the system for the company. And secondly, we want to increase the output as per requirement. From the data given, there are two different parts in line A, which is X1 and X2. That's why we use data table to divide it into two parts. If X1, it will go through all the station. But if X2, it will skip the drilling process. That's why we use method to skip the drilling process. And this is the coding that we use. We put the method in controls at exit for milling process. That's why it will skip the drilling process if the part is X2. After all the process is finished, the part will load to the forklift. Forklift for line A can carry 20 parts in one time. This is the coding for load 20 parts. And this is the coding for unload the part to the buffer. Forklift will move 2 minutes to assembly station. We use this formula, length of track 10 meters divided the time 120 seconds. And we get the speed of forklift, which is 0.083 meter per second. After unloading, the part will separate in two different buffer, buffer X1 and buffer X2. We use this coding to divide the two different parts. For line B, X3 will go through all the station, but in line B, there are 50% defect. So, in control, we use percentage as the strategy and tick the blocking to make 50% defect. At line B, forklift only can carry two parts in one time. This is the coding for load two parts to the forklift. And this is the coding for unload the part to the buffer. We use same formula to get the speed for the forklift, and we get 0.01389 meter per second to move the parts to the assembly station for 12 minutes. Part for X4 is supplied directly to assembly station. In assembly station, we need all four parts X1, X2, X3 and X4 to do the process for making A1 product. In assembly station, we use this attribute to make new product A1. Also, in assembly station, there are 5% effect. We use same way as line B to get 5% effect, which is using percentage as the strategy and tick the blocking to make 5% effect. As we can see, this is the final throughput. 354 throughput in 8 days, 2.76 per hour and 66.37 per day. This did not satisfy the company target, which is 500 product of A1. That's why we need to do some improvement to make 500 product of A1 in 8 days. As we can see, this is the setting for event controller. And this is the shift calendar that we use for this project that run for 8 days. A simple validation are made where 5 replications are used with a two-tailed t-test. Using a 95% confidence interval, we can conclude that the result of the output for the base model for this company is valid as it lies in between the boundary. Kinzo Precision Engineering Srinabahat set the target which is 500 parts in 8 days. After going through with Kinzo base model, we can see that the design has a bottleneck occur in milling, grinding and polishing for assembly line A. That's why for the first improvement that can be changed in assembly line A is convert a single station at milling, grinding and polishing as parallel station with attribute of 2 for X dimension and 1 for Y dimension. We use parallel station because we can make two parts in one time for each station and can save more time. After changing the station from single station to parallel station, we can see all the bottleneck in assembly line A are solved and the flow of the process from each station in line A are more efficient. For assembly line B, Kingzo base model did not have any bottleneck. But after do some changing in assembly line A to reduce the bottleneck, we can see at assembly line B has produced not enough parts. So, we decided to change all the single station to parallel station that involve in assembly line B, starting from bending, drilling, and grinding, except control. The attribute that we use for all parallel station is 2 for x dimension and 1 for y dimension. This allows more part to be produced to keep the whole assembly running as we need it. We also change the capacity of buffer x1, x2, and x3 from 6 to 7. This because we can temporarily hold more parts while waiting assembly station finish assemble all parts together. Lastly, time for assembly station is cut in half so that parts from buffer are released faster. We can see the throughput for this improvement is 586 product in 8 days. This improvement satisfied the target for this company, which is 500 parts in 8 days. That's all from me. Thank you.
Assalamualaikum, my name is Muhammad Nasir and I will talk about improvement model number 2. The first thing we do in this model is we converted two single station into a parallel station with attribute 2 times 1, which is in milling station and also the grinding station. While in polishing station, we reduce the processing time in half. These two things we do in this line is to eliminate all the bottleneck occurred. In line B, we convert all the single station into a parallel station with attribute 2 times 1. This is because to balance the number of part produced in line B with the number of part produced in line A, as the number of part produced in line B has 50% of defect. Moreover, we increase the number of capacity in buffer X1, X2, and buffer X3, which allow more parts to occupy the buffer at a time. We increase it from 6 part to 8 part. Last but not least is we reduce the processing time in the assembly station in half, so more product can be processed. And we can see in the final report, we can see 674 parts are produced in 8 days with a throughput per day 126.375.
Assalamualaikum, my name is Muhammad AMIRUL HUSNI. So I will be explaining about our third improvement here for our project, where we need to get 500 output of new product. So basically for our first simulation here, we only managed to get 354. So we do an improvement and we managed to get 672 of new product. As we can see here from our statistic report, we get 672 new product, 5.35 per hour, 126 per day. So basically what we change here for production line A and also production line B is we change all of the station to parallel station. As we can see from our first simulation here, we only use a normal station for production line A and also B. So so in the parallel station here, we can see that we use 2 dimension for X and 1 dimension for Y. So why we use parallel station is because parallel station have more processing places and also it can save more time. So the second changes that we do is on the assembly station here, where we use 2 assembly station, because when we use 1 assembly station, it get bottleneck and it is very slow. So we use 2 assembly station here, because so when the part from x1, x2, x3 and x4 go to the first assembly station, so when the first assembly station are loaded or packed, it can go to the second assembly station, so meaning it can produce more product and also save more time. So as we can see here from our first simulation, we only use 1 assembly station. So okay, as we can see from this table, we can see that our first improvement we get 586, and our second improvement we get 674, and our third improvement here we get 672. So as we can see that we choose our second simulation here, second improvement, that we can see that we reach our goal where we needed to get 500 output of new product, but instead of getting 500, we get 674 output of new product. So the reason why we choose this simulation is because it eliminate bottleneck. At the same time, it also minimize the bottleneck in the simulation. So and also the output of the second simulation here is more than all of the uh, output of the improvement we do. Think that's all from me. Thank you very much.